chemical reactions. Okay. In the previous classes, I explained you that chemical changes takes place because there are some reactions that are happening, right? Chemical changes takes place because there are some reactions. There are some reactions that are happening. Okay, some reactions that are taking place. These reactions are chemical reactions. Okay, and they are of various types, various kinds, and some of those types we are going to study in this chapter. Okay, now the first type of reaction that we will study is a combination reaction. Okay, combination reaction. Now you can identify this from the name combination, that in a combination reaction, a new substance is formed through the combination of two or more substances. Okay, formation of new substances by the combination of two or more substances is known as combination reaction. Okay, for example, A plus B. A is one substance, B is another substance, will together form AB. That is a new substance. Okay. For example, A is one substance, B is another substance. They combine together and form AB, which is a new substance. Okay.
Excuse me, ma'am.
Yes, Hannah.
Ma'am, I just joined, ma'am. Could you repeat, ma'am?
Yes,
Voice.
Hannah. Yes. It's okay, Hannah. I just started with combination reaction only. Okay. I just began when you joined. We just started the combination reaction in which two substances combine to form a new substance. Okay, take a look at this example. When quicklime, quicklime is a substance. Okay, when we combine it with water, what we get? Slaked lime. Okay, quicklime is a substance, water is another substance. When we combine them together, what we get? Slaked lime. Okay, CaO is the chemical name for quicklime. H2O is the chemical name of water. When we combine them, we get CaOH2. Okay, why OH2C? CaO plus H2O. Okay, you can see that O here is there. Okay, H is there. 2H. H is how much? H2 means 2H is there. And O is, one O is here and one O is here. So how many O? 2O. And how many H? 2H. So Ca is only one. So Ca I'm writing outside the bracket. And then OH2 means O and H are 2. Okay, 2 of O I'm having. 2 of O and 2 of H I'm having. So it results to slaked lime, the chemical name for slaked lime, which is CaOH2. Okay, this is combination reaction, where two substances are combining to give a third substance, to give a new substance. Okay, now one more thing I explained you during chemical reactions, during chemical changes, is that chemical reactions, uh, how do you identify it as a chemical reaction? There are some things that happen alongside or as a result of chemical reaction. Okay. Some things are produced as a result of chemical reaction. Those things are heat. When a chemical reaction happens, heat is produced, light is produced, sound is produced. Okay, heat, light, sound, gas is produced. So these are some things that happen when a chemical reaction is happening. Okay, now see, for different chemical reactions, different things may happen. For some chemical reactions, it will produce heat. Okay, some chemical reaction, it will give a sound. Some other chemical reaction will give light. Light will happen when a chemical reaction is taking place. Some other reaction, yes. Okay, so, and also there is one more, there is also smell. Okay, there is also smell, odor, smell. For some other chemical reaction, it will give a smell. So for different types of chemical reaction, different types of outcome, it will happen when the reaction is taking place. So here, in the reaction of quicklime with water, what we are getting? Heat. Okay. As a result, it is producing heat. This is your combination reaction. Okay. Now tell me, any doubt in combination reaction? Any doubt in combination? Any questions you want to ask? No? Okay. All right. Now see, here is an activity. Here is an activity in which a small amount of quicklime is taken in a beaker and water is slowly added to it. Okay, slowly added to it. And then you touch the outer surface of the tumbler, of the utensil, the vessel. You will feel it warmer. Okay, you'll feel it warmer. Why so? Why is that happening? Because heat is being produced in this reaction. Okay, it will feel warm to your touch if you place a hand because heat is produced in this reaction. Okay, a large amount of heat is produced during the reaction, which raises the temperature of the reaction mixture. Okay, temperature rises. Now, the next type of reaction is called decomposition reaction. Okay, it is called decomposition reaction. In this reaction, this is the opposite of combination. Okay, this is the opposite of combination. For example, I have a substance AB. I have a substance AB. My substance AB will break down to give two new substances A and B. Okay. In the combination, A and B were combining to form AB. In decomposition, one single substance, one single component will break into two parts and give two new substances, two or more new substances. Okay, that is your decomposition reaction. Okay, an example is CaCO3, which is limestone. Okay, it breaks down to give CaO and CO2. Now see, I will tell you the breakdown. Okay, CaCO3. When you heat it up, okay, here in the presence of heat, when you heat it up, it breaks down to give you CaO. Means one O. See here, O3 means I'm having three O. Okay, O3 means I'm having three O. So one O is here. Okay, Ca and O. Now what is left? What is left is this C and two O's. This C and two O's is left. So what will happen? CaO plus this C I will write C, these two O, one O and two, CO2. Okay, CaO plus CO2. This is a breakdown of CaCO3. Okay, now decomposition reaction happens when a change in the nature, a change in the surrounding of a substance takes place. For example, either it will cool down, either you will cool it down or you will heat it up. Then it will break down into two components and will give you two substances under decomposition reaction. Okay, this is the opposite of combination reaction. All right. Now, any doubt in decomposition reaction?
No.
No? Okay. All right. The next reaction is called displacement reaction. Okay, the next reaction is known as displacement reaction. There is no diagram, so I will show you with the help of a diagram. Check this out. We have two substances. One substance is AB and the other substance is C. Okay, what happens is that when these substances are combined and a reaction takes place, when these substances are combined, reaction takes place, one of it gets displaced. One of it, what's the meaning of displaced? It gets moved from its original position and goes to a different position. Okay, it gets moved from its original position and goes to a different position. So the small b thing with A moved from A and went to C. Okay, the B thing moved from A and went with B. Okay, so here before it was AB plus C. After the reaction, it became A plus BC. Okay, displaced. We got displaced from its place. Okay, this is known as displacement reaction. Okay, one reaction I will show you. One more reaction I will show you. Sorry. Okay, see, we have two substances. We have zinc and copper sulfate. Zinc is my first substance. Copper sulfate is my second substance. The reaction between zinc and copper sulfate is happening. So copper will get displaced, and zinc and sulfate comes together and copper gets displaced. Okay. A zinc plus copper sulfate will give you zinc sulfate plus copper. Okay. Zinc plus copper sulfate will give you zinc sulfate plus copper. Okay. A displacement. Okay. A displacement of copper. Copper is displaced in the reaction. So this is known as displacement reaction, in which one element gets displaced from its original position. Okay. So now tell me, did you understand displacement reaction? Yeah. Any doubt in displacement? Yeah. Okay. There is a little bit level up of displacement reaction. Okay. A modified version of displacement reaction known as double displacement reaction. Okay, known as double displacement reaction. What happens in double displacement reaction is that two, both the sides, two compounds are present. Both the sides, two compounds are present, and then they just go on and displace each other. Okay, then they just go on and they displace each other. That's your double displacement reaction. Okay. Exchange of ions between the reactants are called double displacement reaction. Exchange of ions also takes place. Okay, how? I'll explain you with a diagram. AB plus CD. Okay, one element is AB, the another one is CD. When the reaction takes place between these, A is there, but B and your D gets displaced and change positions. Okay, change positions. So your AB plus CD becomes AD plus CD. Okay, means some elements they get displaced from their original position and change places. Okay, now see. Now try to understand a little bit about change of ions. Okay, change of ions. Now, in a double displacement or double displacement reaction, the cations and anions of two compounds switch places. Okay, the ions of two compounds they switch places. Okay, A and C are positive. Do you know that? Have you heard about positive charge, negative charge? Ever heard about positive charge, negative charge? Okay, substances having positive charge, negative charge, or positive ions, negative ions. Okay, so what happens is that in the this example, AB plus CD, A and C are positive ions. Okay, for example, A and C are positive ions. Okay, positive ions are known as cations. Okay, and negative ions are known as anions. So B and D are negative. B and D are negatively charged. Okay, so what is happening is during a double displacement reaction, during a double displacement reaction, this B gets displaced with D. Okay, D gets replaced with D. Means the negative charges that are there, they switch places. They switch places. Okay, those elements with negative ions, they switch places. So A and C are positive, they remain like that, but D and B will swap places. Okay, that is why is a double displacement reaction takes place. Okay, that is why double displacement reaction takes place. All right, you don't know, you don't have a lot of about elements in level C. Okay, in this 8th standard, we don't have like it in very depth. So we will not go in too much depth about elements, anions, cations, and charges. But for your like information, just to tell you how it works, I wanted to explain you the concept of positive and negative ions. Okay, how it works, how the charges switch places. Okay, that is only you have to remember. How the charges switch places because the ions switch places, double displacement reaction happens. Okay, double. Why also double? Because two are there. Pair of two are there. Okay, that is why double. Okay, and switch places. That is why double displacement. Okay, an example is AgNO3 plus NaCl. Okay, what is happening? NO3 and Cl swap places. Okay, NO3 and Cl will swap places. So it will become AgCl plus NaNO3. Okay, try to understand. AgNO3 plus NaCl. NO3, that is your B, and NaCl means D, are both negatively charged ions. They swap places. Okay, so it becomes AgCl plus NaNO3. Now tell me, did you understand how double displacement reaction works?
Yes, ma'am.
Yes. Any questions regarding double displacement reaction? No? Okay. Okay. These are some more examples. HCl and NaOH. Okay. Hydrochloric acid and sodium hydroxide. Double displacement will take place. Okay. NaCl. Okay, Na will combine with Cl and H will combine H2. Means H will combine with OH, so it will become H2O. Okay, H will combine with OH, so H2O. So NaCl, when NaCl combines, it gives you sodium chloride and H2O is water. Okay. Second one, Na2S plus 2HCl. Okay. So 2 NaCl, Na and Cl combines. So 2 NaCl plus H2S. That is sodium sulfide plus hydrochloric acid gives sodium chloride plus hydrogen sulfide. Okay. That is the reaction. Now, how to prepare this? How to prepare this for exam? You have to learn the definition of the reactions and one reaction example. Okay, one reaction from each type you have to learn as an example. Okay, sometimes it asks that give one double displacement reaction. So you should know any one, any one double displacement reaction you should know. Okay, I will find some easy good reactions and post it. I think last year also I did post reactions for you all to memorize or remember. I'll post some good reactions that you can memorize. Okay, now come to redox reaction. Okay, redox reaction. What happens in redox reaction? Substance when see first, if you've learned this before, when a substance gains oxygen during reaction, when a substance gains oxygen during the reaction, it is said to be oxidized. Okay, we use the word oxidized. Similarly, when a substance loses oxygen during a reaction, a substance loses oxygen, it is said to be reduced. Okay, it is said to be reduced. Now, in a redox reaction, one substance gains oxygen and one substance loses oxygen. Okay, very simple. One substance gains oxygen, one substance loses oxygen. So the substance that gains oxygen called oxidized. Okay, one substance gets oxidized, one substance gets reduced. Okay, one substance gets oxidized, one substance gets reduced. This is a redox reaction. Okay, that is your redox reaction. Okay, now example, example we will see. Fe. Fe is a substance. Okay, is another substance. Now, both react with water. Okay, Fe is iron, O2 is oxygen. When iron reacts with oxygen in the presence of water, okay, it becomes Fe2O3. Okay, it becomes Fe2O3. And Fe, see, Fe is gaining. Okay, Fe is gaining, and oxygen is getting reduced in the reaction Fe2O3. Okay, Fe is gaining while oxygen is reducing. Let's show you one more example. Okay, check this one out also. 2 Mg plus O2, okay, giving out 2 MgO. Okay, so when combination is happening, okay, when oxidation is happening, oxidation means gaining oxygen. Oxidation means gaining oxygen. Reduction means losing oxygen. Okay, so combination of oxygen is there. Okay, Mg combines with oxygen. See, 2 MgO. When Mg is joined with oxygen, it is said that Mg is gaining oxygen. Okay, when MgO means Mg is gaining oxygen. Okay, loss of 2 electrons by Mg, oxidation number increases. Okay, ignore the loss of electrons, ignore the loss of electrons, but we will talk about um, gain of oxygen. Okay, now then what is happening? See, oxygen was O2. When it went here, it just remains to O. Means it lost one of oxygen. Reduction is taking place. Okay, oxidation number decreases. Okay, O2. Okay, O2. So only O is coming here. Okay, in simple terms. So this is um, Mg is getting oxidized while O2 is getting reduced. So in a redox reaction, one substance will get oxidized, means it will gain oxygen, and the other substance will get reduced, means it will lose oxygen. Okay, one substance will gain oxygen, one substance will lose oxygen. Okay, oxidation and reduction. Okay, so that is why it is known as redox reaction. Okay, redox reaction. These are some examples of redox reactions. Okay, some examples of redox reactions that you can remember. You can just remember the easy ones. 4Al, 4 aluminium plus 3 of oxygen gives 2, 2 aluminium, 2 O3. Okay, 2 Al2O3. That is aluminium oxide. Okay, so you can just remember this, or you can just remember this one also. Fe plus O2 gives Fe2O3, or the one that I just did. You can just memorize any one of the redox reactions. Example. Now, any doubt in redox reaction? Any questions related to redox reaction? No. The only thing you have to remember is one compound gains oxygen, means it gets oxidized. The other compound loses oxygen, means it gets reduced. Okay. Reduction is not possible without oxidation, and oxidation is not possible without reduction. Okay. Both are dependent on each other. Both are dependent on each other. Okay, so with this, we have finished with types of reactions. We have studied combination reaction, where two compounds combine to give a new compound. We studied with decomposition reaction, where one compound two or more new compounds. Displacement reaction, where one element compound displaces other from its place. Okay, there is exchange of ions between them. You can just write it as when there is exchange of ions between the compounds. It's a double displacement reaction. Okay, they get displaced from their place because of change of ions, exchange of ions between them. Then we talked about redox reaction. Okay, in which oxidation and reduction of the compounds take place. Okay, these are 5 reactions. These are important from the exam point of view also. One reaction we should know. Okay, we will stop here for today. We will stop here. Tomorrow, we will talk about acids, base, and salt. Okay, we'll talk about acids, base, and salt. Do you know after you finish this lesson, we'll do an activity, an experiment. Okay, after we finish this lesson, we'll be doing an experiment based on the lesson. Okay, what it is a surprise until we do it. So you can anticipate it. Once we finish with the lesson, we will be doing an experiment. Okay, that's all for today. 5 minutes break for you. and then we'll be starting with the maths class. Okay, we are starting. It is on, please. Hi, Joshua. Good afternoon.
Yes, ma'am, good afternoon, ma'am.
Okay. You all have time by this week's end, okay, to finish fifth chapter. Okay, all the exercises, back questions of fifth chapter, and Monday I will be taking a doubt class of fifth chapter, algebra chapter. Okay, Monday I'll be taking a doubt class of algebra chapter. Okay, in which I'll be taking your doubts. Okay, so any doubts from any of the exercises, you just finish it till then. Okay, Abija, you can do whatever you're able to do. Okay, the questions that you're able to do from what I've taught recently. Okay, subtraction and multiplication. You can try that out. Okay, today we will start a new chapter, fractions. Okay, today we will start a new chapter, fractions. Okay, now first with the meaning of fraction. What is a fraction? What is a fraction that we are going to see? Okay. For example, I have a pizza. Okay. I have a pizza. Okay. Which has four slices. Which has four slices. Now, fraction can be used to denote a part of a whole. Okay. A part of a whole. Say if, let's suppose, if Joshua ate one slice. If Joshua ate one slice. Okay. And I asked you, how much did Joshua eat? Okay. Joshua ate one slice, and I asked you, how much did Joshua eat? What will you tell me? Then one fourth. Okay. One fourth. What is this one fourth? What exactly is this one fourth? One fourth means that four means the whole. How many slices were there as a whole, or in total, how many slices were there? Comes in the form of denominator. Okay. And how much did Joshua eat was one slice. So one will come on top. One fourth. Okay. Yes,
Excuse me.
Hannah. Yes, Hannah.
Ma'am, what chapter is fractions, ma'am?
Fractions is chapter 8. Lesson 8 is fractions. Okay. Now,
Ma'am, eighth chapter is percentage and its application.
oh, 1 second. One second. Hmm. Okay. We are doing the 8th chapter only. Okay. Percentage and its application. But before starting with percentage and the application, because the chapter is going to use fractions, okay, I want to introduce the topic of fractions. All right, because the percentage chapter is going to use a lot of fractions. Okay, so I've started fraction portion as an introduction for you. Okay, and then we'll move on to percentage. Okay, so that you can get where we are getting these fractions from. All right, a little bit intro about fractions, and then we'll move on to percentage, the 8th chapter, percentage. Okay, fractions we're doing as a part of the topic. Now, so 1/4 is considered a part of the whole. Okay. In the same way, if three of the pizzas are eaten, if you all have eaten three pizzas, I can represent it as 3/4. Okay, how much you've eaten? 3/4. So this is what is fraction. Okay, this is what is fraction. And fractions are also used in percentage. Okay, we are going to see many fractions in percentage and gonna do it together. Did you understand a little bit basic about fraction? A part of the whole? Yeah. Okay. Okay. Now, now what happens is that sometimes the mathematical values are represented represented in a way that 100 is the base. Okay, sometimes the mathematical values are represented keeping 100 as the base. For example, I scored 90% in my 12th standard. I scored 90% in my 12th standard. So 90%, okay, or 90%. What is that? That is not a value, that's not a number of any particular subject. Okay, that's not a number of a particular subject. But out of 100, it is a value that is quantifying my marks, average of my marks out of 100. Okay, so in percentage, the base is 100. The base is 100 means whatever you are giving a value to 20%, 30%, 80%, 60%, anything, 23%, 48%, anything. The base is 100 means out of 100. Okay, out of 100. So 100 is also something that we're going to use a lot in this chapter because the base for a percentage is 100. Okay, now at the beginning of your chapter, we have a question. Okay, we have a question. What the question says is, compare. Sometimes we have to compare values which are not just values, but values which are in the form of a fraction. Okay, when values are in the form of a fraction, what we will do? We will compare them. Okay, and how we will compare them? Let's take a question and see. Okay, so your question is compare 3/8, which is a fraction and a value, and 2/7. Okay, compare 3/8 and 2/7. Now, one interesting fact is that you cannot compare a fraction until its denominator is same. Okay, you cannot compare a fraction until its denominator is same because 3/8 and 2/7, I cannot tell which one is bigger. Okay, but to compare that, the denominator should be the same. Okay, so for that, what we do is LCM. LCM. Okay, we take LCM for the denominators. I'm doing it on the side. You can make like this. You can write 8 and 7. Okay, now see, LCM is lowest common factor, which means that such a number which is coming in the table of 8 and in the table of 7 both. Okay, we have to find such a number that is coming in the table of 8 also and 7 also. Okay, so here it is easy. You can just say the table and just find it out, or you know the tables, you can just tell it is 56. Okay, it is very easy. But for bigger numbers, when you get bigger numbers, you can do this LCM method. Okay, with 2 fours are 8, 7 as it is, because 7 nothing goes, 7 doesn't come in the table of any other number. 2, 2s are 4, 7. Okay, 2, 1s are 2, 7 as it is, and 7, 1 as it is, and 1. Okay, so you can just multiply it. 2 into 2 into 2 into 7. Okay, you can multiply it like that. What you will get? You will get 56. Okay, so now what happened is, now the base is 56. We know that the base is 56. In the table of 8, how many times 56 comes? 7 times. In the table of 2, oh sorry, 7, how many times 56 comes? 8 times. So when you are multiplying this thing, that in the table of 8, 56 is coming, how many times you have to write that? In the table of 7, 56 coming, how many times you have to multiply the denominator with that? You also multiply the numerator with that same number. Okay, the number with which you are multiplying the denominator, that number only will multiply the numerator. Okay, 8 into 7, because in the table of 8, 7 is coming 56 times. Okay, to get the numerator 56, okay, I will multiply. And numerator also, you have to multiply. So write down 7 times 3, by 56. And here 8 times 2,
In by
by
56.
56. Now when both the denominators are 56, I can tell that 21 by 56 is greater than 16 by 56. Or you can also write it as 3 by 8 greater than 2 by 7. Okay. This is comparison of fractions. If you get question on comparing fractions, number one, we take the LCM of the denominators. Okay. And find the common denominator. Number two, we see that this in the 8, how many times in the table of 7, how many times it comes? With that number, we will multiply both the numerator and denominator, and both the numerator and denominator. And then what you will get, you write, and then you'll compare, because the base is same now. The base is same. You can compare the numerators and write. Okay. Any doubt in this question?
No, ma'am.
No. Please write this down and let me know when you're done writing.
Done,
And
ma'am.
I'll give you one question to try. Okay. Abhija, done writing? Okay.
Then, ma'am.
Okay, Zoe, done writing?
Actually, no, ma'am. Just 1 second. I'm almost done.
All right.
Excuse me, ma'am.
I'm almost done.
Yes, Hannah.
Ma'am,
Okay.
after this, ma'am, could you show us the proper way to write this in an answer?
Proper way to write this in an answer. Hannah, this is the way you can write this in an answer. Okay. These are all the steps that you can use. Okay. In your notebook, there is the whole page. Okay. So at the side, on the right hand side, you can just make a line like that. Okay. And on the top, you can write rough column. Okay. On the top, you can write rough column. And whatever addition, subtraction, LCM, HCF, multiplication, division, whatever calculations is needed in the main sum, na, you can do it in the rough column, this side. Okay, not very big, not half the page, but a small space on the side. Okay, you can make, and then in the rough column you can do all the calculation, and in the rest of the page you can write the sum. Okay, that is how you do the calculations. Okay, shall I clear the screen now? One question I will give you to do. Okay, one question I will give you to do, you to solve. So you have to solve it and tell me the answer. Compare 9 by 10 and 4 by 50. Start solving this. Compare 9 by 10 and 4 by 50.
Um, excuse me, ma'am.
Yes, Hannah.
Ma'am, while doing LCM, ma'am, should we start with the lowest uh, common factor, ma'am?
Uh, yes, Hannah, you can start with the lowest number.
Ma'am, I sent you an answer.
Okay, Joshua, let me see.
Ma'am, even answer.
Okay, Eva. Okay, Joshua, that is correct. Okay, Eva, that is also correct. Good one.
Ma'am, are you going to give another one?
Another one. Okay, you can do another one.
Ma'am, I sent you an answer.
Okay, Joshua. Yeah.
Ma'am,
Yes, Joshua.
ma'am, you had sent homework yesterday. Was it the homework that I had sent you before, ma'am?
No, Joshua, I don't think so.
Okay, ma'am.
Mhm.
Thank you, ma'am.
Yeah. Yes.
Ma'am,
Yes, Eva.
I answered, but like it's 1-5. Okay.
Okay, Eva. Yes, Zoe, that answer is correct. Oh, uh, you answered me with a LCM number, Eva. Yes, that's it.
Ma'am,
Hmm. Okay.
is it correct?
And let me see, Eva. Let me solve and see. Eva and Joshua both gave me different answers. So I have to verify for the second question. First question, Eva, Joshua, Zoe, same answers and everything. But second question, I have to see. Hmm. What is 8 by 25 and 12 by 15? So we can just take an LCM of 15 and 25. Okay. 3, 5 is 15, 25. 5, 1 is 5, 5 is 5, 1, 5. Okay, so 5, 3 times 5 times 5. What what was the LCM that you guys got, Eva and Joshua? Because the LCM that we'll get is 75. Okay. Now 75 divided by 25 is 3. So 8 into 3 upon 25 into 3 we can do. Okay. And 15, 75 divided by 15 is your 5. So 12 times 5 upon 15 times 5. It's okay, Abhija. I will explain once again. Okay. Yes, Joshua.
Ma'am, which question is the second question or first?
The second question I'm talking about. This question, 8 by 25 and 12 by 50. Okay, so 8 times 3.
Excuse me, ma'am.
Yes, Hannah.
Ma'am, in the second question, ma'am, is 12 by 15 greater?
That is what we are checking, Hannah. That is what we are checking. Yes, 12 by 15 is greater. Okay, 12 by 15 is greater. That is the answer. Okay, now come back to, I'll explain you this question again. 9 by 10 and 4 by 50. Okay, now first we will take a look at the denominators, the numbers below are denominators. Okay, we draw a line like this. We draw a line like this. Okay, we write smaller number first, then the bigger number. Okay, now next what we do is we start with the table of 2 and we see that in the table of 2 if these numbers are coming, if no then we move to 3. If it's coming the table of 3, then we see. If not, then we move to 4. Like that we move in an LCM. Okay, so I'm starting with 2 because 10 and 50 both are even numbers. I know that both will come in the table of 2, so 2 I will write. Now in the table of 2, 10 is how many times 10 is coming? 2 5s are 10, right? 2 5s are 10. So 5 I will write here. 2 5s are 10. In the table of 2, 50 is coming how many times? One trick. Just half of 50. Okay, half of 50 means 25. Okay, in the table of 2, 50 is coming 25 times, means 2 into 25 is equals to 50. Okay, so I will write here 25 because in the table of 2, 50 is coming 25 times. Okay, then 5 and 25 are not coming in the table of 2, so skip 2. Not coming in the table of 3, skip 3. Not coming in the table of 4, we will skip 4. 5 in the table of 5, I'm getting 5 also, 25 also. So 5 I will write outside, make a line. And in the table of 5, 5 is coming how many times? 1s are 5, 1s are 5. Okay. Then in the table of 5, 25 is coming how many times? 5 times. 5 5s are 25. So I will write 5. Okay. Now I have 1. When it ends with 1, now see LCM always ends with 1 1. Okay. Always ends with 1 1. Now 5 I have. So 5 comes in the table of 5 how many times? 1 time. Okay. So 1 1 comes. What will be the LCM? 2 into 5 into 5. Okay. 5 5s are 25. 25 into 2, 50. The LCM is 50. Okay. So what I will do? Now in the table of 10, in the table of 10, 50 comes how many times? 5 times, right? 10 5s are 50. So I will do 9 upon 10. Alright, and then 10 5s are 50. Okay, so into 5. Because I'm multiplying 10 with 5, 9 also I'll multiply with. Okay. Now 4 upon 5, 4 upon 50 I will write. Okay. So 50, 50. Okay, so into 1 means as it is. The other one will remain as it is. Okay. Just the first one I will solve. 9 5s are 45, 45, and 10 5s are 50. And 4 ones are 4, 50 into 1, 50. Okay, now we will compare 45 upon 50 and 4 upon 50. 45 is bigger or 4? 45 is bigger, so 45. Okay. Now did you understand, Abhija? Yes. Okay. So this is how you compare using. Yes, Eva.
But my LCM is 100.
You got your LCM 100.
Yeah, and the first question.
Okay. The LCM is not 100. Okay, it is 75.
Ma'am, first question.
First question. 3 by 8 and 2 by 7. This one. Not understanding what should be.
Ma'am, 9 by 10.
9 by 10. Okay. Mhm. Oh, this one. All right. You got your LCM as 100. Okay. That would give you the same answer, Eva. Okay. That would give you the same answer. But I would suggest you use the lowest common multiple, means LCM. Okay. The lowest multiple you use that's what I would suggest. Okay. Now, clearing the screen, and I'll teach you one thing. Okay. Converting percentage to fraction. Converting percentage to fraction. We will also learn how to convert fraction to percentage after this. First, we learn how to convert percentage to fraction. Okay. Now, first question. Percentage I have is 45%. 45%. Okay. What I have to do is 45 upon 100. Okay, 45 upon 100. Now see, whenever you see the percentage sign after a number, okay, it means that the base will be 100. It just means that upon 100 means the base will be 100. 45% means 45 upon 100. What you will do, you will cut. Okay, means you will reduce them. You will reduce that. How to reduce that? 45 and 100 both are coming in the table of 5. Okay, so we will reduce with 5. How many times? Okay, how many times 100 is coming? 5 twos are 10 and 0. 45. How many times 45 is coming in the table of 5? 5 nines are 45. 9. Okay, 5 nines are 45. And 100 comes 20 times. How I did 20 times? See, 100 is there now. I'm checking out with 5. Before 100, I have 10. 10 comes how many times? 2 times. 10 comes 2 times. 2 and 0 as it is 20. Okay, 0 as it is, so 20. This is what I did. So what I get 9 upon 20. Can it be reduced more? Can it be reduced more? No. Answer is 9 upon 20. Okay, you get the answer 9 upon 20. This is how you will convert a fraction, a percentage to a fraction. Okay, by dividing it with 100 and reducing it as much as it is getting reduced. Okay, as much as it is getting reduced. One more question. Check out one more question. 16 whole number 2 by 3%. I have to convert it into fraction. 16 whole number 2 by 3%. I have to convert it into fraction. Ma'am, but it is already a fraction. So how to convert a fraction or even a mixed fraction to a fraction? Even a mixed fraction percentage to a fraction. First, we'll solve this. Okay. 16 into 3 plus 2. You know this, right? Hope you know this, that this number and this number we multiply, and what we will get here, this number and this number we add. Okay. The denominator is multiplied with the number at the side, and the numerator is added to the product. Okay. The numerator is added to the product. So I will do 16 into 3, which is 48, plus 2, 50. Okay. So 16 into 3, 48, plus 2, 50. I will write it as 50 upon 3%. Okay, 50 upon 3. Now see, 50 upon 3 is not the answer. Okay, 50 upon 3 is just a percentage, just a more sorted form of a percentage. Okay, but now 50 upon 3, what I will do? Into 1 upon 100. Okay, into 1 upon 100. Multiply 50 upon 300. Okay, because 3 into 100, 300. Now cancel 0 with 0. Okay, I have cut 0 with 0. Now I will reduce. 5 ones are 5, 5 6 are 30. 5 ones are 5, 5 6 are 30. Answer 1 by 6. Okay. Answer will become 1 by 6. Okay. What we have done, we have first converted it into a normal fraction. Okay. See, there are three types of fractions. Just take a quick look here. Fractions are of three types. Okay. Number one is mixed fraction. When you have a small number here, 2 1 by 4. Okay. Three numbers. This is known as a mixed fraction. This is known as mixed fraction. Okay. Number two, 50 by 4. Okay. You have another concept of proper fraction and improper fraction. Okay. Proper fraction and improper fraction. Now, proper fraction and improper fraction is based on the numerator and denominator. Okay, when the numerator is bigger than the denominator, it is known as improper fraction. Improper fraction. When number three is when the numerator is smaller and denominator is bigger, it is called proper fraction. Okay. Three types of fractions: mixed fraction, improper fraction, and proper is when denominator is bigger and numerator is smaller. Improper when numerator is bigger, denominator is smaller. Okay. So this mixed fraction, now when you convert it, when I convert two whole number 1 by 4 into a normal fraction, like I'll multiply this 4 to the 8 plus 1, 9 upon 4. 9 upon 4. When you convert a mixed fraction, you will always get an improper fraction. Okay. When we are converting a mixed fraction, you will always get an improper fraction. All right. That is for your information because we are going to convert in this lesson. Some conversions will come. Okay. Hope you understood the conversion. Multiply the side digit with the denominator and add the numerator to it. Okay. Add the numerator to it. That is your converting mixed fraction to improper fraction. Okay. Now come to the question. So what happened? What we did is that we converted it to improper 50 upon 3. Then we multiplied it with 1 by 100. Why 1 by 100? Because 50 by 3 is in the form of a fraction. Okay, so 1 by 100, not just 100, 1 by 100. Okay, we'll keep it in a fraction form. Multiply the denominators, multiply the denominators. Okay, and then whatever you'll get, you can cancel it. Okay, and then you will get the answer. Okay, whatever you get cancel and you'll get answer. Yes, Anna.
Ma'am,
Yes.
will you give us questions to do for ourselves?
Yes. I think in the homework today, I'll be giving you questions to do by yourself. Yes, Eva.
Ma'am, you multiply by 1 by 100 to make it a proper fraction, right?
Say again. Can you repeat that?
You multiply by 1 by 100 to make it back to a proper fraction, right?
To make it a proper fraction, yes, you can say that, but it is mostly to convert it into a fraction. Okay,
Okay.
you can say that. Yes. One more type. Just learn one more type. Okay, one little type. I'm clearing this. One last question. 0.5%. Then the percentage is in decimal. Okay, or we can just take 11.5%. Okay, a bigger number, a little bigger number, 11.5%. What to do now? What to do when it is in decimal? When it is in decimal, you can just do 11.5 into 1 upon 100. Okay, so there's something that we do is removal of the point. So when you remove this point, it will become upon 10. Okay, 115 upon 10. That's what it will become. Okay, so now you will cancel it. Now you would want to cancel 115 upon 10. Okay, with 5 we can cancel. 5 to the 10. 115 divided with 5. 115 we'll divide with 5. 23 we will get. 23 times. Okay, 23 times. So what I did, I'll just quickly explain you again. See, 11.5. Okay, so when we're removing a point now, when we're removing this decimal, we will put 1 beneath it, and however, whatever digit is after the point now, that much 0 I will put in the denominator along with 1. Okay, if it was 1.15 and I want to remove the point, it will become 115 upon, like put 1 and 2 digits, so 2 zeros. Okay, this is how you remove the decimal point in fraction. Okay, that is how you remove the decimal point in fraction. So that is what I did here. We removed the decimal point and put 1 0 beneath. So it became 115 upon 100. Instead of 11.5, it became 115 upon, not 100, sorry, 10. Okay, then you divided 115 and 10 with 5. 10 comes in the table of 5 two times, so I wrote 2. And 115 comes 23 times, so I wrote 20. Okay, you may have to divide and check. Now what my fraction became? What my fraction became? 23 upon 2. Now we will do this step 1 by 100. Okay, now we will do this step 1 by 100. So 23 upon 200. 23 upon 200 you will get. And 23 upon 200, can it be cancelled? No, it cannot be cancelled because one is an odd number, one is an even number. So this is the answer. 23 upon 200 is the answer. Okay, so when you will get it in point, what you have to do? You have to first remove the point. Okay, just write this down, Eva, and then you can leave. Okay, I'll tell you the homework also. After that, you can leave. Okay, just write the remove the points. Okay, and then multiply it with 1 by 100, and then what you will get will be the answer. Okay, any doubt in this? 3 types of converting fraction to converting percentage to fraction. 3 types of questions we learned. One is normal, one is mixed fraction, one is decimal. Any doubt in this?
No, ma'am, done writing.
Done writing? Okay.
Done.
All right. All right. Let me just tell you the homework. The homework is 8.1 question 2. Okay. 8.1 question 2 is your homework for today. Okay.
Give me now.
Yes. Yes, Johanna.
First name.
The what?
The chapter's name.
Chapter 8. Chapter 8. Percentage and its application. The 8th chapter. Okay. Exercise 8.1 question 2 is your homework. Okay. That's all for today. Now we'll be meeting tomorrow. Bye bye. Have a good day.
Bye, ma'am. Thanks, ma'am.